There are a few things in Java that can sneak up on you and bite you. I'm sure I don't know all of them, but I will show you some of the ones that I know have caused trouble. The Java compiler has an error message that serves no purpose whatsoever beyond being an irritant. In Java, all values are initialized to 0, always. It's part of the definition of the language, and one of the features that makes a Java program safe and secure. But unless you put in specific code to initialize a variable, the compiler spits out an error message that says it may not be initialized. That's silly. It would be a valid complaint for a more primitive language like C or C++, but it's nonsense for Java. As a result, you will see Java programs that contain useless code to initialize things to 0 or null or false. The only thing this code is for is to get the compiler to shut up and compile the class. The code does nothing else. In fact, the optimization stage of the compiler takes the code out. We all miss a keystroke from time to time and misspell the name of a variable. Most of the time, this results in a compiler error, but there is a certain way you can misspell and the compiler won't notice it. Instead, the program compiles fine, but it doesn't do what you intended for it to do. This is an example. This class has two internal variables. The values of the two are set by the constructor, or are they? This one is misspelled, and that means that this statement doesn't do what you expect it to do. The value of minimum is assigned to itself, from itself, instead of from the argument. All this program does is create an object of itself and display the two values. Here's what happens. One of the values was initialized, but the other one remained 0. Now, it's easy to see what happens in this example, but you can understand how a simple misspelling like this in a large program could be one of those sneaky and hard-to-find errors. The generic macros being added to the language has caused a number of problems. The first time I noticed generics was when some of my older code quit working. The installation of a new version of Java caused an existing program to no longer be viable. The classes would no longer compile because some of the previous classes were rewritten and had macro definitions added to them. To be able to continue using that code, I had to reinstall an older version of Java. I like version 1.3. With the addition of macros, Java is no longer a context-free grammar. The less than and greater than symbols have different meanings depending on the context in which they are used. The same is true for the keyword extends and for the ampersand. When you use generic macros, you eliminate the capabilities of polymorphism and inheritance. At least with macros, these capabilities are changed in some very odd ways that I don't completely understand. In the next lesson, there are a few more gotchas. This is a continuation of a list of gotchas from the previous lesson. Everything in Java will convert to a string if it's combined with another string by a plus sign or the plus equals operator. Generally, if the item on either side of a plus sign is a string, then the item on the other side is converted to a string, and the two strings are then concatenated into one another. But the plus sign, being responsible for two very different operations this way, can lead to an ambiguity. This program demonstrates what happens when you combine int values and strings. In this first example, two int values are added onto the end of a string. In the second example, the same thing happens except parentheses have been added around the int values. The last two examples add the integers to the front of the string. In the first example, just the two numbers are added, but the second one adds a zero-length string between the two. Here's the result. In the first two examples, the parentheses make all the difference. In the first one, the two numbers are converted to strings before they are added. In the second, the parentheses cause the numbers to be added first, then the result is converted to a string. However, when the two numbers are in front, they are added first even without parentheses. Placing a zero-length string between them forces the string conversion to come first. Now, the conversion takes place from left to right, so you can code it that way, or you can use my solution and insert zero-length strings between items and not worry about the order. You know that the equal sign will convert anything to a string if the target, the item on the left, is a string. That is documented in the original Java language definition, but some other conversions have slipped into the language. Look at this. This example creates an integer object and then assigns it to an int data type. You would expect this to produce an error from the compiler, but it doesn't. This assignment operation causes the content of the integer object to be converted to an int and then assigned to the target value. Here's what happens. The conversion of the contents of an object into a primitive type takes place without comment from the compiler. As more of these things are slipped into the language, it becomes more likely that your compiled code will do things that you don't know about. I can recall these sorts of helpful things being added to a language in the past. In particular, it was the collection of helpful features that killed PL1. After a time, it just became too unpredictable to be able to use, so everybody went back to Fortran where they could look at a line of code and see what it was doing. One last gotcha. Names of classes and things are compound words, and the words are capitalized to make each one distinct, and they have to be coded with the capitalization exactly right, and it's not always easy to tell what the original writer of the code considered separate words. It isn't consistent. For example, checkbox is considered two words in many cases, but it's considered to be one word in others. Combo box is always considered to be two words so far. Pop-up is considered to be one word. Also, the words input and output are both considered to be one word each. Callback is also considered to be one word. Now, particularly tricky are the double capital words like JLabel and the triple capital words like IOException. I'm sure there are other gotchas hiding here and there. I just don't know what they are yet. But as you can see, the Java language is still mostly its sturdy, well-defined self. But who knows what's coming? You have just been through an explanation of the things that are new to Java in version 6 or have become a part of the Java language in the later versions. Java is never still. Not only are new things being added to the language, but alternate and hopefully better ways are being added to do things that Java already does. The most dramatic of these alternate ways of doing things was the addition of Swing for the development of GUI interfaces. Swing is sort of based on the previous AWT technology, and there are several places where you use AWT classes to complete Swing, but you shouldn't try to use the two different interrupt models in the same program. They may work, but they may not. Some of the things added are radical departures from the original language. Both generics and annotations are different languages inside Java. Generics in particular are a departure from the original concept of Java. A few of the things discussed in this course came from older methods being deprecated and newer ones being added. A prime example of this is the number of methods deprecated in the date class, with new methods doing the same things being added to the Gregorian calendar class. A lot of the things presented here were actually added in Java 5. For example, generics, the for loop : syntax, boxing and unboxing, which is that curious thing about certain classes automatically converting to and from fundamental types, enums, annotations, and a few others like variable length argument lists on methods. But most of the things covered were either augmentations or additions to Java 6. Among these is the collections framework, which makes heavy use of generics. Also, there is WebStart, NewIO, the additions to Lang and util, instrumentation, serialization, and internationalization. But not everything in the course is new. A couple of things, such as threads and networking, have been staples of Java for quite a while, but they were included because they are fundamental and sometimes tricky. Java's not through. Someday there will be a Java 7, then an 8, and so on. I could tell you what I think is going to happen, but I'd be wrong. Nobody can predict computer languages. At least in the past, nobody has been able to. It's like predicting the weather. If you predict that tomorrow will be like today, you're usually right, but that's not the way to predict the big stuff.